Welcome everybody to Lecture 3, Database and Information Systems in the winter semester 25-26. And here's what we're doing today. I will say something about your experiences with exercise sheet 2, the exam and the exercise sheets in general. There's no lecture next week. As I said, we had a number of free spots. They are just 3 weeks every month, so 1 week free, and that's the one for November. So you have 2 weeks for the next exercise sheet. Today we will talk about database basics, and I will try to talk a little bit faster because we have more material than usual. You see here 40 slides, and you see some red thingy here, which I will just leave. This is what we will talk about. The exercise sheet will be fairly basic, but still very important. Gather some movie data, design some database tables for it, load them into a very nice database, relational database management system, and then try your first SQL queries. Who here in the room has already written SQL queries in their this or previous life? Okay, a few of you, and let's just go on. And Zoom chat, if you have any questions, just feel free to ask. You can also use the audio if you want. Here's your feedback from exercise sheet 2. The sheet was really nicely built on the first one, was fun, but took me a little longer than the first one. Yes, the first one was pretty simple. I really liked the amount of feedback from the last time, so several of you are doing that very well, giving your tutors feedback. How much feedback you want, that's really important for us. And I read all the comments. Some people say, please give me a lot of feedback. Other people say, I don't need any feedback, and let's just fine-tune it that way. I had problems with the worksheet, mostly because I haven't programmed in a too long time. A number of people said something like that. I had a lot of difficulties with this sheet. On a positive note, I've learned a lot about debugging, which is a similar vein like this was, so several of you seem to be out of practice. Was a little bit overwhelmed by this week's lecture since it transported so much information at once. This exercise was really absurdly hard for me. Interesting, but I did not quite understand all the precision formula stuff. So there was a surprisingly large fraction of feedback about having difficulties with the lecture. It's interesting because it's very similar to a lecture we have given in the past, where the feedback was not quite like that. So I wonder what's going on. Maybe you have other stuff that's too much work. We would like to know about it. Please let us know. So seems, I mean, it's the second week. Also, a number of people wrote that they are sick. We would like to know what's going on. So I have the feeling it's maybe about something in the surrounding circumstances. We want to know it, please. Okay, your favorite quote or movie scene, that was very interesting. Robin and I watched all of them. The coin toss scene from No Country for Old Men, so everything is, we will not watch videos now, and I'm very proud of you for your good taste in movies. Mines of Moria from Lord of the Rings, hello there, from Star Wars. Life Finds a Way from Jurassic Park. We have a quote missing here, and I have to add that. There's always time for this. And PowerPoint is not adding the right type of quote. We have the bank robbery scene from the movie Heat, one of the best shooting scenes of all time. I can tell you there's a lot of shooting in that scene for 10 minutes straight, made over 30 years ago. Heat is a very famous movie. That's from the movie Seven, highly recommended. Ernest Hemingway once wrote, that's what Morgan Freeman says in the very end, the world is a fine place and worth fighting for. I agree with the second part. It's a bit dark, but the movie is a bit dark. Every scene with Wall-E gives me a good mood instantly. Who knows the movie Wall-E? Okay, that's great. The others, you have to watch it. There will be exam questions about it. Okay, very briefly about the last exercise sheet. The results, it was fine-tuning, playing around with BM25. And let's briefly look at the result table, which was here. For those of you who didn't do the exercise, that was the result table. So Robin set some baseline. I will also have it on the slide. Here were the measures, so there were some training queries, testing queries. You tuned your parameters. Here you see them. You could also use other heuristics. And here you see, so Robin's baseline had a mean precision of 3 of 0.58. Somebody achieved 0.75 and so on. So interestingly, there were these two parameters, B and K. So B close to 0 means do not adjust for average document length, as you hopefully remember from the last lecture. So this corresponds to very slight adjustment, but not 0. So it's slightly above 0, right? You see it here on the slide. The good ones, 0.1, 0.0, not 0, and you played around with it. You tried to get best possible results. Many of you ended slightly above 0, interesting. Small value of K also gave the best results, which means TF star values, yes, not only binary, but between 1 and 2. That's what K equals to 1 means. So yeah, if a word is very frequent in a document, make the TF a little bit larger than 1, but not a lot. These were the baseline results by Robin. These were the best results you achieved. So somebody achieved big improvement in mean precision at 3. For the others, only slightly improvement. And one thing I wanted you to take home from here, just a second, or maybe right now.
Should be 48 in NPR, 45.
45 here?
Yeah.
The best is 45? You just computed the maximum on the fly?
I mean, the table, I don't see 48.
You don't see 48? Yeah, maybe somebody corrected there, 40. Thank you for paying attention, 45. And also there were some changes from when I did this slide. And look at these numbers, that's quite interesting. So mean average position is really looking at the position of all relevant documents. So to get, if you want 100% here, you have to get for every query all the relevant documents at the top. And that's extremely hard. So you might say bar, yeah, it's just the second lecture, so maybe it's harder to get close to 100%. If you look at real benchmarks, real competitions, it's similar numbers. It's very, very hard in search to get even close to 100%. Even 80%, if you're honest, you don't get it. It's extremely hard to get the relevant documents at the top. This is easier, just getting a few ones at the top, getting all of them at the top. There's always one which is hard to get. So that's actually very typical and something you see here. There was a map result of, 50. I think there was even one of 60. Yeah, but I don't believe it. It's not consistent with so which is why I added here. That's another problem with these kinds of things. Of course, you could have a small mistake in your code. So somebody reported a map of 60 and it's a clear outlier, and if you had that number, maybe check whether you had a mistake. I don't think it's correct, but I'm not sure. If you don't have any questions, let's go on. So number of people who submit is, it's optional, it's up to you. Here's a message for those of you who don't do the exercise sheet. So for the exam, you need this stuff anyway, especially writing code. Writing code is just look at the exam from previous years. Writing code is an important part of the exam. And writing code, like so many things in life, is practice, practice, practice. And this is something I know many of you have this mode where before the exam, 1 or 2 weeks, you sit down and then you do all this stuff. This works particularly bad for coding, because coding is practice, and practice you need over time. So only practice makes perfect. So really, and we know that from experience, that there are people who obviously don't have practice in coding in the exam, so don't be one of those. Do at least the coding, even if you don't do all the exercise sheets. Really important. Yeah, and of course, I mean, if you don't do the exercise sheets, you just listen here, you don't really, I said that in the very first lecture, only by doing it you realize whether you have actually understood it. Typical symptom is, for those who don't participate in the exercise sheet, shortly before the exams, there are lots of questions. There is an error on slide 5 of lecture 3, but it wasn't told to us after lecture 3, but only when you prepare for the exam. So it would be good to get that feedback early on, meaning that you paid attention early on. Yes, please? The exam is on paper, yes. But you write code on, you can write 10 lines of code on paper. So please reconsider doing the exercise sheets, at least some of them. I highly, highly recommend it. So that's it for organizational stuff. If there are no questions, let's just start. Database. Very nice lecture today. A lot of material, but relatively simple. And take the opportunity to interact and ask if anything is not clear. A database stores its data in tables. Lots of examples on the slide, so 40 slides. It's not a lot of information on the slide. Here's our first table, and we stay with our movie scheme. It's actually the top 4 from IMDb. Shawshank Redemption, Dark Knight, Inception, and Fight Club. Here's the year when the movie came out, and here's the IMDb rating. Shawshank, top of all times. So that's a table. You have a header. It's really a database table. It's very much like you think of a normal table. So you have a header row saying what each column is about. And then you have 4 rows here. Header rows is not a real row, just saying what the semantics is. Yeah, a table can be empty. So if it just has the header row, no contents, we say it has 0 rows. So this has 4 rows, not 5 rows. I think that's clear enough by just looking at this table. That's a database table. That's what we're talking about today. I will just talk relatively fast about the simple stuff so that we have more time for the little more complex stuff. Interrupt or ask questions at any time. And don't look in your laptops or mobile devices, but watch the lecture if you're in the room. The relational model. So, let me show the whole slide. So if we make this a little more formal, this is also relatively easy. You have the columns, it's just a tuple of the headings. What we have seen on the previous slide, title, year, score. This is the domains. So the title are strings, years are integers. For now, scores are floats, and it shouldn't be score, it should be rating. Okay, so and the rows are a multiset, and I will say in a minute what a multiset is. So here we just have the rows. They are also just tuples and a set of tuples. Set of tuples means the order is not important. Okay, I will just go on. Sets versus multisets. That's very important. It's simple but important to understand. What's the difference between a set and a multiset? Here's an example. That's a normal set. Set means order is not important. A set contains each element at most once. That's a multiset. So you have the 7 contained 3 times, which means size, the cardinality of this multiset is 5. That's a multiset. Simple enough. The original relational model, there's a small mistake here, it should be relational. So the original database paper, which this relational model, so everything is tables and defined like on the previous slides from 1969, it just said sets, not multisets. So you can't have the exact same row multiple times. It turns out in practice you do want to have it multiple times. So for this lecture we allow multisets by default. You will see that in a second, you can tell the database, please disallow multisets. So if you have a row another time, so the exact same row a second time, it should say map. But that actually costs time and space, so you usually don't do it. Let me just continue. Yeah, order, sets, neither sets nor multisets have an order, which means, so that's also something important to understand, Even if you insert the rows into the table in a particular order, the database can store them in any order. So you have no concept of order in a table. So in particular, sometimes the database say, oh, actually if I sort them this way or that way, I can do my work more efficiently, and the database can do that. If you need an order of your rows, simply add a column. Yeah, let's go just back one slide. You can just add a column here to this table, like rank or row number, and then just say 1, 2, 3, 4. Then you can order it by the row index if you want to. But now you have an additional column which costs additional space and time and whatever. So you should think about whether you really need it. And most database systems also allow you to have this counter automatically. So you can just say, and we will see in a second how these things work in principle, say, please, whenever I insert a row, add a column which is an automatic counter and auto-increment it. So add a first row, it will automatically get this column entry 1, 2, 3, 4. But as I said, that costs time and space. So you should only do it when you need to, and it's also not the default. So by default, you don't have an order and you don't have such a column which says which row index is it. Now in a real database system, this will become clear very soon. If you want to have some fun, you need more than one table, and we will see many examples in the following. And different tables, they are typically not disjoint, but they share columns. Otherwise, you can't really, it doesn't really make sense. We will see that. And the first big question, and also what the first exercise sheet is about, you have some data set, and again our data set will be movies, and it will be movie data which you collect yourself. And let me briefly go to the exercise sheet. You have 2 weeks for the exercise sheet. It's a really nice exercise sheet. You should do it. So let me go back and forth from the exercise sheet. So the first exercise sheet is we have selected 4 movies for you. And of course the first exercise 0 is to watch all of them. And there will be questions in the exam. Like at minute 23, what does so-and-so say to so-and-so? Forrest Gump, Django Unchained, The Silence of the Lambs, and A Beautiful Mind. They are all from IMDb Top 100. And what you should do, we deliberately do not give you the data for the movies, because if we give it to you, we would already give it to you in some format. You should really do what you do when you work with databases. You have to find the information yourself. So just go to IMDb, go to the pages of these movies, or you can also go to some wiki data page and just collect release year, IMDb score. Robin, can you make a note? That should be rating. We always say rating. Find out who's the director, who's the producer, at least 3 of the actors, not the whole cast, at least 1 male and 1 female, and also which characters they played and all their Oscars from these 6 categories: Best Actor, Best Actress, Best Supporting Actor, Best Supporting Actress, Director, and Best Picture. So your first task is just for 4 movies, collect the data in whatever way. And now you have that data, and now you have to put it in tables. And that's what half of the exercise sheet is about. How do you put it in tables? In one table, many tables, which tables, what are the column names? And that's what we will talk about now. It's the contents of the first half of this lecture. And that is known as database design, and that's super important. It's the foundation for everything. And typically, this is where it goes wrong in practice. So HIS-in-1, for example, which you all love and use on a daily basis, has a database design which is just abysmal. Yeah? And this is very common in practice. And this is if the database design is abysmal, everything else on top of it is abysmal, and you can't really fix it. So you learn how to do this properly, so that when you work for HIS-in-1 or other companies, when your time comes, you will do it properly, I hope. Which means you have to pay attention now and do the exercise sheet. So it's very, very, very important, database design. It's the first step for everything. You have to put it into tables in a meaningful way. And that's what we will talk about in a second. Once you have it in tables, you can ask queries, and there's the second part of today's lecture, and there's a query language for that, and it's called SQL. That's the query language for databases, for relational databases. I hear some whispering. For some reason, the whispering becomes very loud in the front. So maybe delay the whispering to the break. Thank you very much. Structured query language. Basic SQL. SQL was a language that was designed for being readable almost like a sentence. Here's an example, and you can almost, if you have never seen, it should be rating. I changed from score to rating. Frank, thank you, and see you again after the lecture. And maybe you can leave the door open. Okay, Frank is not listening. Maybe can you open it? And Frank is... thank you very much. Maybe there's a little thingy there. I will just continue. Thank you very much. So here's, I want movies, the title, and their rating, where the score should be rating here as well. And you can see it while I'm adding the slide, where the score is at least 8.0. I mean, even if you have never ever seen SQL before, you can read this like a sentence. That's the point of SQL. It's relatively verbose. You can read it like a sentence. Of course, more complex queries, then it can become more complex. And we will start learning a little bit of SQL today. And the exercise sheet is also a little bit of SQL, but just the basic stuff to get started. So it's a very, very gentle introduction to databases. SQL is a standardized language, but since this is so widespread in the world, everybody needs databases. There are all kinds of dialects and different extensions, but the core is really the same for almost all database systems. Today we will not rigorously define SQL. I will just tell it to you by example, and I think that's good enough. And then in the next 2 lectures we will be a bit more rigorous. So, before we continue, let's just do some stuff in practice and use a database system. And we will use, it's SQLite. I will talk about that in a second. First, some terminology. RDBMS, it's what you call these systems. Relational Database Management Systems. Relational Database Management Systems. RDBMS, that's actually what you find in the literature. There are RDBMSs on the market, many. Here are some which you might have heard. MySQL, the big open source one, PostgreSQL, Microsoft SQL Server, SQLite, Oracle, MariaDB, IBM DB2, that's like a dinosaur. SAP has their own famous system, HANA. There's still a score instead of rating. There was a comment in the, let me just check that. Now I corrected it, yes, thank you. And for the lecture in the exercise sheet, we will use SQLite 3. And SQLite 3, there's a question on the exercise sheet. That's a very, very interesting system. And let me just show you one thing. I don't know if you saw it. So databases are everywhere, right? Even in your mobile phone, in your car, probably in your washing machine, certainly in every operating system. How many users of SQLite, how many databases? So just an instance, so we will use it now in the lecture, that counts as 1. How many of these do you have? Just think about a number and what would you guess? Maybe you saw it on the slide. What do you think right now across the world, how many people use SQLite 3 for something? What would you guess the number is? Yeah? 3 billion? 3 billion machines, okay. And it's actually, they're very proud of it, and it's written here, and it's, they are over 1 trillion. A trillion is a very large number. A trillion is really a very, very large number. A trillion, and there's a page where they say why that is. If you go here, every Android device, every iPhone, every Mac, every Windows machine, every browser, every instance of Skype, most TVs, most autos and so on. So so we are talking about some pretty fundamental stuff here. The other interesting thing about SQLite is it's essentially by a very, very small team of people, essentially one person. And investigate a bit about that person, has a very interesting life story. And I will say not so much more in order of not to spoil it, but there's a question on it on the exercise sheet. SQLite, Lite, these products which are called light, either they don't contain a lot of sugar, but just other kinds of sugar which are as bad for your health, but that's not why it's called light here. It's light, easy to use. Yeah, database systems can be monsters, and we see a lot of monsters here in dinosaurs. SQLite is actually not a monster. It's really nice and easy to use, but still pretty powerful, which is why it's so popular, and we will use it. I really like it. It's great. I mean, it's not the most efficient database in the world, but it is reasonably efficient for many applications. And I will just provide a crash course for you, and we will just do some hands-on stuff. So here are some, and I will not go through the slides. These are for reference. We will just do that together. These slides are just for reference. Let's just go to the here. And so on the slides, it just says what are basic SQLite commands, and we will just do it live here, and so that you see it. So I have, this is our movie table. It should look familiar from the, and can you see it in the last row reasonably well? Great. So, and let me do one more thing. Set list here. This is okay. There's obviously some title. This shouldn't be spaces. This should actually be tabs. Let me just correct this. Yeah, and you see this character here says that it will be important. Okay, so these are actually tabulation characters. It's shown as many spaces here, but it's actually just one character. And let me just turn it off again. So we have tabulator, we have the heading, title, year, rating, and then that's just the table we have seen on the slide. So it's just in a TSV file, and I will TSV, here you see it, movies TSV, tab separated values. Very, very, very common format for text files where you have things in rows and columns. And you need a separator. Very often it's the tabulator. So if I go here in NeoVim or Vim, it's GA, the letter G and the letter A, and then it will tell you this is actually the character hex 09 or 9. Maybe we can just do it here in a separate. That's the ASCII table. 9 is HT, stands for horizontal tab. There's also a vertical tab. Nobody uses that. That's from the old times when terminals were line-based. You can also have commas as separators, then it's comma separated value. Did you have a question, or was it just stretching? Yeah, just stretching is very good. Please stretch from time to time. So, let's use SQLite. First thing, and I will just install it. Couldn't be simpler, except for the typing. Sudo apt install SQLite 3. To type my password 1234. It's already installed. So now I've installed it. Let's just call it. It's actually, it has an interactive mode, very much like Python. If you just call Python, you go into interactive mode. Let's use it in interactive mode. And the first thing, we want to import this into a table. So let's say, okay, I have to say what separator I have in my table, and the separator. And now here's the difference. There are commands which are SQLite commands, and they start with a dot. So these are commands to the database systems. And then there are queries, they don't start with a dot. This will become very clear in the rest of the lecture. So this is just dot says SQLite. Please, the separator should be tab. And let me just go to the slides real quick. How do you type a tab? Because a tab usually has a function in most terminals. If you want a tab as a symbol, do Control V and then type the tab, then you get the tab. Because if you just do tab, it usually does something in a terminal. It's on the slide. So now I've set the separator to tab. And maybe, let's just import this. Import this file, movies TSV, into a table called movies. So just read this, and internally it should be in a table. Movie cannot open movie TSV, and I think the reason is I'm not in the right directory. So we'll just repeat that. And now, what's really hard, first thing you have to learn is how to quit a program. Exit. Okay, it's not so easy. You have to quit. Also doesn't work. You have to do .exit, I think. Yes. So quitting is not as easy as you think. Maybe if you press Control-C enough times. Here's the table. Let's just do it again. SQLite 3. And now we can be a bit faster. Separator. Oh, actually, is there? Yes, there's a command line history. That's nice. So arrow up, down, I get my previous commands. Here I import movie. Now it's there. Wonderful. Let's ask our first. So now there's another dot command. Show me which tables you have. I have one table, movies. Show me the schema of a table. The schema is what columns does it have. Here's the schema. I didn't create the schema explicitly because it was in this file. It could deduce the schema from the table. So it says here a title, year, rating. So it shows that as the column names naturally, and it says it's all text. Actually, let me just do that again and in a different way. And let me write a file now with the commands. Interactive is nice for playing around, but typically you want to write that in a file so that it's persistent. And you call these files SQL. So let's do that and do the exact same thing here. So a separator, and then again Control-V, tab. Okay, and now we want to import movies TSV. Well, actually, let me do that over here, because that's our. So let me edit the file here, the movie SQL file. Yes, so this is my thing, the table, and this is so import movies TSV into a table movies. And before I import, let me now create, let me be explicit about how I want the table. And let's go to the slide. How do I create the table? And again, it's really, you can read it, create a table, call it movies, and this is what we call, so we have a column title, and it's of kind text. A title is a string. We have a year, it's an integer, so you do have data types. I didn't specify them. Again, there's a number of score things here. Let me quickly correct this. I'm sorry. I changed all these to rating. Rating, 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 and rating, more rating. Please pay attention when you see more ratings, no more score. Score is a bit unspecific. Okay, let's just do that. So create table movies. And now we do title text, and here int and score. Why does it say score here? Rating, real. So that's the way. Int, integer, I think both are text. Maybe it's varchar. Is it varchar in? That's what you said, Robin, right? Yeah, it depends. Text, you can use text, you can also say varchar. These are the small little details. This means a sequence of characters of variable length, but you get the idea. Import movies. Okay, I think that's it. And let's just do it. And now here comes a different mode. So now I can pipe this into SQLite 3. And let's do one more thing. Let's have a query. And let's just take the simplest query possible, which is just select everything from movies. Just show me all the rows in the movie, which will essentially reproduce this file, but now from the internal representation. So I hope that's super clear. Set the separator to tab. This is the table I want to have. And maybe this is just showing the schema of the table, just for to get some feedback. Import the file into this, and then show me all movies. Now there's a dot missing. Oh yes, you're absolutely right. Thank you very much. Exactly. So that's what I said. So these are SQL commands. You don't have a dot in the beginning, but you have a semicolon in the end for the commands to SQLite 3. You have a dot and no semicolon in the end. Bit confusing. And now, so I can take this sequence and so cut is just outputting the file, and I just pipe it into SQLite 3. And now it just, did this, so it created this table, and then it just outputted the table again, but now from the internal representation. Now everything worked in memory, and let me just remove that. I think the way to comment something out in SQL is minus, bit strange, but that's how it is. So what I can do now, I can also give a file name here, and it's typically called db. And now I just do the same thing. I read it into a database, and now it's persisted in a file. So now I have a file, movies.db, which contains this huge table. Movies.db, 8 kilobyte. We can look at it, movies.db, and it's some, you can actually see that there's something in there. It's a binary format, but the strings are in there in some form. And now what I can do, I can always take this. So this is now SQLite 3, the database containing this, and now I can ask a query directly. Select star from movies. Now I get all the movies, or maybe where rating is greater than 9. Now I get only, simple enough. That's SQLite 3. I think I convinced you. I hope that it's very, very easy to use. So please play around with it. I mean, other database systems, you first have to set up a crazy amount of stuff, a database server and super user and blah, and it takes days and you get very frustrated. SQLite 3, it's just like I showed you. And the biggest problem is forgetting dots and semicolons, as we did just now. So please ask any questions if you have any, and then I will go back to the slides. And now before the break, let's talk about design. And there are no questions in the chat or here, so everything seems to be super clear. I hope it is. Before the break, we just have, it's 11 slides, but simple slides, but pay attention because you need that for the lecture. So we have seen this table, and it's this table, this one. Is this the right way to put movies into a table? That's what we will talk about now, and please think with me when I show you these examples and ask questions. So assume we want to have cast information. So each movie, the actors in the movie and which roles they play, something like this. How do you do that? And it's very typical. Think of this in one. You have students have addresses, students participate in lectures and they write exams for lectures and have grades in that lecture. It's a very, very typical database thing. How do you put this information in a movie? Now the problem is, one movie, it's not that one, so far it was easy. One movie has 1 year when it came out and one rating, but that's not typically what you have. One movie has a lot of actors playing in it. And one actor can even play several roles. So how do we do that? And that's the big question actually. You always have this situation. You have many values. And let's look at some ideas how to solve this. Here's our first idea, and spoiler alert, it's not a good idea. You just do it as follows. So here are some of the actors in these 4 movies. Morgan Freeman, Tim Robbins, Rita Hayworth, Morgan Freeman, Christian Bale, Maggie Gyllenhaal, and so on. So is this a good way? And spoiler alert, it's not. This is terrible. So it's probably that's how it's done in his in one. If it's terrible, it's done there. Why? Just assume, so this is now a text in the database. You have a piece of text which is comma-separated values of actors. Now think how you want to query this. If I want the number of actors, now I have to extract that string, split it by comma and count. I mean, this is not very semantic, right? I have many values, I put them separated by commas in the table. That's not the right way to do it. Another way, which is actually not on any of the slides, I could have multiple columns, but then the number of actors is variable, right? For some movie it's 1,000 maybe, or 100, so how many columns do I put? Do I put 100 columns just for the case I have 100 actors, leave them empty, and I have more than 100, then I don't know what to do? This is actually a problem with the relational, with this table approach. How do I do that? And here's the next solution. And so we just have, we do this. So if a movie, and let's just make it simple here, so we just have, let's take The Dark Knight, and we just have 3 actors, so we don't list the others. We just repeat it 3 times. That's certainly how you can do it, and that's not so bad. That's actually the kind of results which you very often get when you query databases. Why do you get it? Because the result from a database system is always a table. So you can't, so if you have results and they all share the same something, like the same title, you have to repeat it. You don't get structured things or trees or JSONs or something like this. You get a table, so you have to repeat stuff. So you see this in databases, but that's not a good way to start a database. So yeah, it's not that bad. Some of our queries have such results, but you should not create tables like that. So how do you actually do it if that's not the right way? Here's next attempt, already a little bit better. Have a separate table, cast, and it's actually, we want to call it roles. And let me just rename it here. I thought I renamed everything. Cast is actually a keyword. So I have a separate table like that. So I have my table where I have the movie information, also the year and the rating, so I don't have to repeat that. The only thing I have to repeat here is the title. Can you tell me what could be this is a little bit more subtle now. Think about it a little bit. What's the problem with this approach? Yeah?
There could be 2 movies, different movies with the same name.
Yes, that's exactly. There could be another movie, The Shawshank Redemption. And then, for example, these might be 2 different movies, and then you don't know who is playing and who. And that's actually happening a lot, and I have a slide about that. So, yeah, there are 3 movies called All Quiet on the Western Front. Remakes are very popular in Hollywood. All Quiet on the Western Front, 1930, 1979, 2022. And actually look at this, okay, not now. So how does Wikipedia actually handle it? So Wikipedia pages have titles, and they are disambiguating it by putting stuff in parentheses, right? They're saying this is All Quiet on the Western Front, 1979 film. Okay, same for actors. There are 2 Anne Hathaways, one the contemporary one, and the other one from 1556, wife of William Shakespeare. I didn't know he had a wife, but apparently he had. So names are very good for human communication. When I say Anne Hathaway, you probably think I'm meaning that one, but if you have a lot of knowledge like computers, then things are very ambiguous, so you need identifiers. We just saw how Wikipedia does it. So you just add something to the string to make it unique, but that's not how you do it in databases. You use IDs, and that's what we're going to do next. And there's more cast here. I'm sorry for all the editing, but yeah, there it says roles down there. And thank you, PowerPoint, for auto-correcting my quotes in the wrong way. AI going rogue. AI, yeah. So here's the table roles now, which says, okay, that's already what we have here. Okay, I'm very sorry. Bear with me. Another one. Robin, we have to be more careful with the slides. I thought I changed everything yesterday. Okay. So what we do now, in our original table, we add an ID, and that's now an ID. The ID can be anything that's, that is an ID, that uniquely identifies the table. So this is just like before, text, integer, real, for we used varchar, that's the same thing, here we used int. Have an additional column, which is now the ID. We also do that for persons, and we also do that for roles. And let me show you an example in a second, and I think here it is, and there's again cast. I did correct that, maybe I have the wrong, I hope. Maybe I don't have the latest version, I'm sorry for that. So here are now 3 tables. Sorry for the back and forth with the slide. That's now our new table. This is very much how you do it for the exercise sheet as well, but there are some design decisions here. So the ID does not have to be a number. We deliberately added the Q here. This is actually the Wikidata ID. Let me show that to you real quick. Shawshank Redemption on Wikidata. So unlike Wikipedia and Wikidata, identifiers are not human readable names because Wikidata is one database for all languages. So it would be kind of unfair to pick labels from one language. So they have these identifiers up here, that's Q172241 from now on for the rest of time. And here we have it, so the ID can be a string. Of course, in reality, you wouldn't maybe add the Q because then it's a number and things could be done more efficiently. But here, for the purpose of explanations, we will do it. So these are our tables now. And here we have a table persons. So it's just persons. And these look good now. And this is a typical table now, which is harder to read for a human, but very good for a machine. And what does it say? And maybe I just very briefly add the names of the tables to these things. So that's now my table movies. That's now my table persons. Should be called persons. And that's my table roles. And just add that it's persons here. So let's just look at what this says. So this says Q172241, which is the Shawshank Redemption, has this actor. Q48377, which is Morgan Freeman. You get the idea. And the nice thing is, now I'm using IDs, so even if there are 2 Morgan Freeman, they have the same name, or 2 Anne Hathaways or whatever, but they will have different IDs. By using the ID here, I solved that problem. And IDs, they should be unique, otherwise they would not be an ID. Any question about that before we continue? Now primary key and foreign key, that's actually very easy to understand now with this example. Somewhere there's a table where you introduce the ID, and that's this table, and that's the primary key. Primary is just where do I introduce it. In the table for the movies, I introduce movie IDs. Every movie will get one ID, and then there are tables using these IDs, and they are called foreign keys. Very simple concept, you just have to know that these are the words. So these are foreign keys because they're using the ID from that table. And let's just see how you, that's just written here. And that's how you do it. The previous slide was just what I said. So I'm creating a table movie, ID, key, and I'm now telling the database, and we will talk more about why it's a good idea to tell the database, this is the primary key. here I'm having the table persons. This is the primary key for the persons. And now I have the table roles. And it was this table here, the roles. And this is using IDs from these tables. How do I write it in? I write it like this. So this is a movie ID. It's text. It's not an int because I have the Q references movies ID. That's just how you write it. So this is an ID, and it's actually the primary key from the table movies, which is called ID. You just have to know how to write it. Yeah. And actually, there are a lot of stuff that's going on when you explicitly tell the database system about this. So, for example, it will check that your primary keys are unique. Otherwise, they're not unique. Try to create another row with the same primary key. It will say map. I already have that, and it will do some other checks. Any question about this? Okay, let me go on. And I think, let's just do that together, and then 2 more slides, and then we have a break. And let's just. So actually, what I did, I already entered these movies here, refined. And let's just do the following. -O will just, let's have all the TSV files, and let's have a SQL file again at the top. Yeah, so, and let me just go here and just check. So these are the table from the slides. And set list will just, party time again. So, this is the table. Let's just check whether everything is all right. This just means it's a tab character here. Yeah, it's just in TSV form, the tables which I've seen. Any questions about that? I think it's exactly what we had on the slides. And now, let's just write our SQL commands for importing it into a database. So let's just do that. How do we start? We start with the separator. Control V tab. And now let's create the tables with the schema. So it's create table movies. And now we have to, this is something you have to learn. So it's ID, text, and then was it primary key? Yeah, it was like this. Primary key. And now we have a title. Let me write text again, not varchar. It's the same thing. I have here int, and I have rating real. And please tell me if I make any mistake. And now let's start with the next table, create table, persons. And persons is very similar. So I have an ID, I have a text. It's the primary key. The person has a name, which is a piece of text, and they have a birth date. I just added that so that a little more interesting information in there. That's it. And now this is a table. This is the table roles, which references the other 2 roles. It should be table roles. And now I have a movie ID, so I don't have to call it ID here. I shouldn't. It's called ID in both of these tables. Here it's different. So movie ID, which also text, and this now references the other table, movies ID. And let's just end the other one here. And I don't have I did some auto-completion stuff here, and semicolon. Does it look correct to you? Person ID, text references, that's what we had on the slides, yes? Okay, let's just, break will be there very soon. Refined. That's what we have now. Let's do, like we did it before, cut movies SQL into SQLite 3, so it will just execute these commands. And it worked fine. Let's just add Fight Club again with a different name. Let's just say there was a remake in 2929, so very near future. Now we should get an error because it's a primary, it's a second movie with the same primary key. Let's just see whether it complains. It doesn't. Okay, I'm disappointed. Why doesn't it complain? Okay, we have to find that out. I'm very disappointed. I was expecting a complaint from, so maybe you can, yes, why didn't it, you want to complain instead? Sorry? Oh, I didn't import the files yet. Yes, thank you. Thank you. Import movies, import persons, yeah. Okay, I just created the tables. Thank you for paying attention. I didn't import the files, so nothing to complain yet. Hopefully now. Thank you. Insert failed, unique constraint failed, yeah? I said this is a this is unique, this is an identifier. Here I have a second one. So let's, yeah, so I was, and now it just worked. And now let's do it like before. Let's persist it in a file. And now movies.db contains our 3 tables. So it's really, really simple. So we can do, yeah, let's just ask which tables are there. Movies, person, roles. Let's just look at the schema of the table, dot schema. It just, the schema, actually I just get the commands I use to create them. And let's ask the first query. Select maybe star from persons. What did I do wrong? Persons, yes. And now we get internal representation of the table. So that's it, simple enough. But now we have already taken some hurdles. Last thing before the break, relationship between these tables. There are 4 kinds of relationships. And yeah, that's just, so let's look at these tables. So here I have one movie. If I take this table and this table, so the movies and the roles, so here I have one movie, and one movie can have several actors. And that's a 1-to-n relationship. 1 to many. So each record in one table can be associated with multiple records in the other table. It's actually very common, especially if table A has the primary key, movie, and then you have multiple actors in that movie referencing that. That's 1 to n. 1 to 1 if it's really, yeah, it's kind of obvious. N to 1 if it's the other way around. And n to m, we will also see that. I have examples on the next slide. So these were our tables. So movies to roles. So just to get that clear again, last question, then we have the break. So it's, so each, what's the relationship of this to this table? And just looking at the ID here, is it 1 to 1, 1 to n, n to 1, or n to m? So the first number says how often it can occur here. 1 if it's unique, and n if it can occur several times. And this, 1 to n, yeah, 1 to n. Here it's the primary key, so it's 1. Each ID can only occur once. Here it's the, yeah, it's not 1 because we see it here. A movie can occur multiple times. So that's 1 to n, exactly. Let's just write it down. So that's 1 to n. Persons to cast. So it's now this table. So you have the person ID to this table. Here it's the second column. Is it 1 to 1, 1 to n, n to 1, n to m? So yeah, so this is the first table, this is the second table. And you have to wonder, can the ID occur here multiple times or once, and here multiple times or once? What's the answer? Yes? 1 to n, and why n? Why the second n?
Because there can be more than movies.
Yeah, one actor can be in more than one movie. And actually we have it here, right? The Q, yeah, 4833, Morgan Freeman actually plays in The Shawshank Redemption and The Dark Knight. So this is the kind of question you have to answer. So can this happen? Like a student can write more than one exam. And one more. Movies to persons via cast. Now these two are related, not directly, right? Now I'm taking this one, the movies, and the persons via this one. And now you have to ask, so these are movies to actors. What's the relationship? Yes? N to M, and can you say why?
Because in one movie there are multiple actors, but an actor can play multiple movies.
Yeah, exactly. So one movie can have multiple actors, an actor can play in multiple movies. Yes. So that's the cast. It's very, very bad. Bad. Cast is a keyword in... I've renamed 100 things. I should have let an AI do it. One more. Where? Person to cast. Wow. Attentional blindness. That's N to M, N to 1. Now I used a different blue, but we will stick with that. Any question before the break about any of this? Okay, let's have a 10-minute break. See you. We're back online again. Everybody back. Doors are closed. CO2 levels are down. So, this was where we left off before the break. And please ask if you have any questions about this. So this is where we'll take off from now and do a little SQL. These were our 3 tables. They are connected via these IDs. Primary, key. This is where you define the key. It has to be unique. And then foreign key where you're using it here for an N-to-M relation between movies and person. One movie can have multiple actors. One actor can act in multiple movies. This is how we created these tables and imported the data. Yes, please.
So the create keyword simply defines the schema for the table?
Yes, exactly. Create just defines the schema. I made that mistake by somehow assuming that it would magically import the data. This just says, this is how my table looks like. Exactly. This creates the schema. You can just omit these, and then SQLite will try to deduce the schema, but what it will typically do it is, if there are header rows, it will just read them and assume it's text. It doesn't do an analysis and say, oh yeah, this is actually an integer. Yeah, but it will ignore, it was smart enough to ignore the first row. That's nice. Any other questions about this? Basically, what you see on this slide is the essence of the first half of the lecture. No more questions, then we just continue. And the rest is just, so SQL, huge language, we will just learn the basics and one very important principle. So the basic structure is like this. Select from where, and we have seen all of them already. Select is what I want in my final result. I want the title and the ranking. From is from which tables. So far it's always been 1, but you can put several. Where is I only want rating at least 9. Simple enough. So select from where, it's really the most typical SQL query, and the simple ones you can read like a sentence. So in this lecture I will not define it formally. That will be happen in the next 2 lectures, but just by example. And this is the example query. We'll just this is the most complex we get today. Let's just look at it. Maybe you understand it already now. You should by the end of the lecture. Select. So we take all 3 tables, movies, persons, movies, roles. Actually, I don't like the order here. So I will just change the order because it doesn't matter actually, but I don't like it. So from, we take all 3 tables And now we are doing some equality, so the person ID from the roles should be the ID from the persons table, and then in the end we want the title and the name of the actor. So what this should do is, for each movie, the people who act in it. The question is, why is it written that way from 3 tables? Why this where clause? What does it mean? And that's something non-trivial to understand, and we will understand now in the next 3 slides. Yeah, and in lecture 4, we will define the semantics more rigorously. So what does this query do? Select star from persons, movies, roles. And maybe I will just, will I have it in that order? I don't know. Let's make it consistent. And this will actually compute what's called the cross product, or also the Cartesian product. And this is absolutely key for everything in databases. So this is also known as the Cartesian product in mathematics. Cartesian product or cross product. And I will have a slide only for this. I'm skipping some slides which are merely for references afterwards. So this takes the Cartesian product of these 3 tables. And a Cartesian product of 2 sets is all combinations where one element is from one set and one is from the other. And the Cartesian product of 3 tables is just all rows, all combination of rows where one row is from movie, one from persons, and one from roles. The question is, why is it done like this? Why does it make sense? We will see that. So in particular, and this will become clear, so the number of columns in the Cartesian product is you just have all the columns from all the tables. Example will follow. And the number of rows is just the product. And it will become clear on the next slide. Let's first understand cross product for sets. Forget about tables, just sets, and I think this will make it very clear. Here are 2 sets. And let's just that's an example with 3 sets. Let's just write something here. Number of elements in the first set is what? S1? Don't be afraid. 2. Yes, it's 2. Number of element in the second set, not even multi-sets, is 3. What's the number of elements in the cross product before we write down the cross product? 2 times 3, it's 6. And now let's write down the cross product. It's also a set. And it's just a set which now contains all pairs where the first component is from the one set and the second is from the second set. So let's just do, it's a set, so the order does not matter. Let's just do A1, B1, that's a cross product. Let me write this funny thing here. Now I do A, 2, B, 2, and now I do A, 3, B, 3. That's the cross product. It's really quite simple. You also need that a lot in combinatorics. Combinatorics is like looking at all combinations. So that's the cross product. And you see that it has 6 elements because you have 2 choices from one set, 3 from the other set. Here's a slightly more complex example. Before I show you, and we will not do this interactively, but you tell me what the, let me just write down. What's size of S1? 2. What's the size of S2? 3. What's the size of S3? 3, yes, and it doesn't all have to, can be anything, the elements. What's the size of the Cartesian product of the 3 sets? You can tell me the final result. 18, yeah, it's 2 times 3 times 3. 2 times 9, it's 18, and here is the set. And of course, if you want to write it down, you need a system, but I think you can, right? This is now all, it's now triples, all combinations where the first one is from the first set, the second from the second, the third from the third. So here I'm, A1, B1, B2, that's all combinations. Any questions about this? Cartesian product you have to understand it. It's the basic of relational databases. But if you look at examples, I think it's simple enough. Any questions from here or Zoom chat? Otherwise, I continue. So what does it mean for our three tables? And here I leave movies, persons, and roles. So the cross product by the multiplication becomes pretty big pretty quickly, right? This is just really small sets, and the cross product is already size 18. So let's not do it with the full tables, but let's just do it with these simple tables. These are just these tables, but I'm just removing some stuff. I'm just making them even shorter, so then I can show you the cross product on one slide. And this, I think, is the main slide of the next slide, is the main slide from the second part. So these are just two movies, Shawshank Redemption and Dark Knight. I also removed the columns I don't need, like rating, I don't want them now. Also birth date, two actors, Morgan Freeman and Maggie Gyllenhaal. And note that Morgan Freeman plays in both movies, so I have some multiplicity here. And this is the roles data. So Morgan Freeman plays in both movies and Maggie Gyllenhaal just in The Dark Knight. And now let's look at that's the dot product, the Cartesian product. And this is now, look at it, stare at it, and it's a lot of data, but it's actually simple enough. So these are from movies. So it's just the first two columns are from the table movie. It's one column from table movie. It's one row, so I have and this is from the table persons. And this is from the table roles. And this is now all combinations, and let's just make sure how many is it? 2 times 2 times 3, right? So 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's just all combinations, and you need some system to make sure that, so this is one table from and actually you can tell that it's right by if you just look here, you should get each movie the same number of times if it's done correctly, and similarly here. So for these two, because these are primary keys, that's a reality check that you should get each key the same number of times. So that's just what I showed you with sets earlier, now with rows. It's all combinations, all possible combinations where I have one row from this table, one row from this table, one row from this table. And let's just do it for the huge tables here. These were small, these are now very large data. Let's just do it from movies. Let's just see whether what I said is movies, persons. Let's just do movies and persons first. Now that's all combinations from movies and persons. How many movies? 4. How many persons? 4. So it should be 16. It's more than 16. Why is it more than 16? Did I do something wrong? Oh, I did. Yeah, it did read the table header, right, for some reason. So why did it, I think I'm a bit, but it didn't read the table header for which one is this?
I think it always read the table header, just you interpreted it as
Yes?
output from SQLite, but SQLite just output every row. So that's what when you
Oh yeah, here it is also. Okay, so actually I have 5 times 5, which is, okay, so how do I not import the table header? I think it was written on the slides. Who knows it? Who's a SQL expert? It's good that we're making these small mistakes, because you will also make them. Oh, actually it wasn't written here with the Maybe you can find it out. I think there is a without headers. And let's just see what. Bam. Okay, doesn't. There's a. Okay, that's a. Where's the AI answer? How do I import without a header? Actually, I know it. It's some minus skip one. I think that's the right one. Minus skip one. That's just skipping the one. Let's just, okay, minus looks like a comment, right? So what's the right? Minus skip? Really? That's weird to have the, but let's just see whether it works. And you can look it up in the meantime, whether it's minus skip one. Let's just remove the database file, but it's great to make mistakes. You learn from that. So let's just do that again. Okay, that worked fine. That looks better. So now, yeah, skip one just skips the header file. Is this 16 now? 4, 4, 4, 4. Yeah, that's 16. So that was movies and person. So all combination of rows where I have one row from this and one row from this, right? And that's the dot product. And now let's do the dot product of movies, person, roles. So actually you get it as a result. If you don't, that's actually the correct result for the query. And now that's what you get. That's the cross product of all three tables. And let's just go back here. What's the size of the cross product of these three tables without header row? 80, yes, 4 times 4 times 5, right? 80. Do you agree? 16 times 5. It's 80. Should be 80. So let's just check it by doing a line count, and it's 80. So that's the result. Yeah. Any question about the cross product? And you can play around with it yourself. And I think it will be so why are we doing this cross product stuff? And now we are going back to one of the slides. So of course you almost never want the cross product. Why would you want the cross product? But the cross product is the first step to get what you actually want. Usually you have a where clause. And now we have the where clause. And now think about it. If I want a movie where this actor actually played in that movie, and I have this roles information, then all I have to do is to check, is this movie ID actually the ID of the movie? Otherwise, this is an irrelevant combination, right? And here it's actually the right combination. The first row is spot on, right? So I have a combination of a movie, Shawshank Redemption, and an actor, Morgan Freeman. And this row here says, yeah, actually, this actor did play in that movie. So this is something to include in the result. And this is exactly what we write in the query. We just say, in the result, only give me those rows where the person ID is actually the ID from the person, and the roles, the movie ID from the roles is the movie. Let me do it again here. So these two, this one is actually equal to this one, and this one is equal to this one. So this is a match. And by just going through all combinations, then I make sure that I do not miss anything. So here I have the Dark Knight and Morgan Freeman. Does this row, this part tell me that Morgan Freeman played in the Dark Knight? No, it doesn't. As some other row will tell me that he played in the Dark Knight, but not this particular row combination. Okay, let's just do that on the, and now one more thing. Let me go to the tables again. I mean, I can have ID here and ID here, so different tables can use the same column header, so I need some this unique way to reference it, and you just do it that way. That's simple enough. Table name dot column name. So if I want ID from the table persons, I write it as persons.id. If I just write ID, I don't know from which table it is. And now let's do that again. Yes, here. And now let's just do the query. And let's just go over the, let me try that. How do I want that? So first row. Is the first row a match or not? You tell me. Is it a match according to our query? You have to check whether movie ID is ID and person ID is this ID. First row match, yes or no? And you, yes, it is. Okay, and let me just write that here. That's movies. Just to make sure that we know where. And this is persons. And you can already scan the table and find the matching rows. And that's also what the database system does. So is this, I'm sorry. Let me maybe do it this way. So is this row, yes, this row is a match. Let's do the next row. Is this row a match, yes or no? No? Next one? You have to play yes or no? No, why not? Movie ID is the same. Person ID is not. Okay. Next one? No. Next one? No. Next one? Yes. Yes, it is. So, your life as a relational database system. Pay attention to your karma or you get reborn as a relational database system. So what's next row? No. Yeah, no. Next one? No. But maybe you like that. Next one? No. Next one? No. Next one? No. Next one? Yes. Okay. Yeah, so one has to be, yeah. Okay. This is actually not part of the last column, I just put it there. So we have 3 result rows. That's our result. That's the result of the query. And let's just do a similar thing here. Let's do it in parallel maybe. So what do we want to say here? Where, I'm getting some reflections here, where movies dot ID is equal to roles dot movie ID. This is really the one thing you have to understand. I have multiple constraints, I just write and. You don't have to write them in all caps, but you just do that so you can see what's a keyword and what's other stuff. And person's ID is equal to roles dot person ID. Does this look correct? Person's ID. Yeah, let's just do the wrong thing and it will tell me, yeah, I don't know that. So you get, and now I get this, now I only get the rows here where it's a match. I get all the information. Let's maybe do it properly right away. Let's just, I needed the IDs for joining the tables. For the output, I usually don't want them. Let me just put title, comma, and title. Now the question, let's be precise. Let's do movies title, comma, person's name. I just want the name. Yeah, this is name and the title. I don't care about the IDs anymore. And now I get this. And actually, I could even just write title because yes, it might occur, but here it's unique. So if the database can infer that there's only one table with title, you don't have to write it. But it's good style to write it. So what I did now is so my tables here are bigger, so I outputted the role and then I only select certain columns, right? And this is now you wrote this thing, and this is the most basic thing you have to understand about databases. You write the query in a way as if you are computing the full cross product and then selecting rows from that cross product. You're always writing SQL queries that way. But the result is then actually what you wanted, the cast from each movie. So the Shawshank Redemption, I have Morgan Freeman and Tim Robbins, and so it's actually the information it's actually just the 5 thing from this table here. The big question is, of course, why does it have to be so complicated? This is something which will become clearer when you work more with databases. So this is actually, it's just the information of this table where I've translated the IDs to the names. And please do ask if you have any questions, and let's just continue with the slide. So the where clause, that's what I just explained. So that's our example queries, and that's what we just explained. Yeah, this gives us exactly what we want, namely for each movie, the people in there, and if there would be roles, you could also add that. I think now from this example, you can imagine how this can become more complex. So for example, in this table, you could also now add role, right? Which role did this person play in this movie? And now, let me say that, now it already becomes, you can see how database design is not so trivial. Assume you start out, you haven't seen these tables yet. Where do you put the information about the role? Do I put it here, here? No, you should put it here. It's exactly the right place, right? This is the table where you have one row that says, this actor plays in this movie, and they play a role. So you put the table. But now it can become more complicated, because sometimes actors play multiple roles in the same movie. Then you would need another table, and then you would have an ID here, which stands for a particular row of a person in a movie. So can quickly become complicated if you have more complex data. And this is what the next exercise sheet is about. So that's now the result we got with our small example, right? We had 3 rows where we had a tick mark, a green mark, and these are the 3. Let's just check again. Movie ID should be ID for each of them. Yes, 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 yes. And person ID should be ID for each of them. And now the select clause, we already did that. It's simple enough. This just says, if I do the cross product, I always get all the columns from all tables. Let me just say that again here. It's a plus, right? So if each of my table had 2 columns, I get 2 plus 2 plus 2. This does not multiply. The number of columns just adds up because I have all columns from all tables. Typically, I don't want all the columns in my result. The IDs are really just for joining them together and not for the output. And here maybe I just want the title and the name. And how do I do that? I just write it in the select clause. So now you understood why I have select from and where, and this we already had. I write the table and the thing from the table. Yeah. And let's just recap. So a query like the above takes the cross product conceptually, then checks for each row whether this condition is true, like we did together, or you might do in a future life if you don't pay attention, and then you just output the columns you need in the select clause. And let's just do it for this table, and I think let's just select the columns which we want, and I think that's just, okay, that's not, it's just this column which I select. Let me just draw it like this, and this column. So select is really just cutting out columns and the other column. Yeah, that's simple enough, and then I get this result, right? And it's always, so I hope that's clear. By selecting rows, throwing out other rows, it's still a table. By selecting columns, it's still a table, just a table with fewer columns. Any questions about that so far? We are almost done. Surprisingly, we might finish on time today. Any question about anything so far before I go to the final 2 slides and to the exercise sheet again? Yes?
How much space does
So the question is, how much space does storing the data mean? Do you mean the original tables or the dot product, the cross product? Mhm. Good question. That's a big topic, but not of today's lecture. So let's just look at how many minus CB, the TSV files together have 398 characters. So this is our TSV files together. DU is just for total amount of space size of a number of files, all TSV file. C just means accumulate, computed total. B just means binary, otherwise I will get kilobytes or something. And let's just do the same for movies DB, which is just one file. Okay, it's a bit bigger, so there's stuff in there, internal stuff, which usually doesn't matter, but when you just have 3 very small tables, we can also look at the movies DB file. Yeah, looks good, right? So yeah, it's a it actually says in the beginning this is some internal format. So the question is, does it use compression? Does it use fancy stuff? SQLite 3 doesn't use compression, so it's actually a bit wasteful. We will learn more about compressions later. Yes? Mm. Yeah? Ah, yeah, that's a very good question. And I have a slide on that, but let me repeat the question and then say it. So the big question is, and I will come back to it on the slide in a second, but let me also say it again. And we had this query earlier. So this is the cross product of all 3 tables. And now we take this cross product, we select, where is it again? Now we have add the where clause, which just selects the rows which we actually want, and then we also select some columns, and now the question is, does the database internally really compute the cross product, then select some rows, then select some column? And the answer is no, it would be a terrible thing to do. Just imagine these tables having a normal size or even a big size, right? But this is the way to understand what's happening, because that's how you write the queries, right? That's the one takeaway from the lecture, that to understand what this query is doing, you have to understand it in the cross-product way. Otherwise, this query doesn't make sense, right? You're putting 3 tables here, putting these where clauses, you understand it in terms of the cross-product, but the database does something differently, and what it does, we will talk about that in the next 2 lectures. That would be too much for today. And that's exactly what's on this slide. So what an RDBMS actually does, it's not how they actually compute the result. It would be way too expensive. Except, let me just emphasize that again, if this is your query, then the cross product is just the correct result, right? Then it has to compute the whole thing. If you do select star from 3 tables, the correct result is the cross product, and you get it. I mean, now you have to compute it, but usually that's not what you want. But you can write it. Yes. And these queries are so typical, and this is what the next lectures are about, that you have special stuff happening. You have a cross product, and then you have this equality constraints on IDs from different tables. And last slide, let's go to the exercise sheet. So for the next exercise sheet, and please do it, you have 2 weeks for it, it's not so much work, start early, do it. You don't care how it computes the result, you just want to learn a little bit of SQL and database stuff. So first exercise it, you gather the data. Did I miss something, Robin?
No.
Okay. Okay, afterwards. Okay. First exercise sheet, collect the data. Now you have to put it into tables. That's why we don't give it to you. so that you're completely free. How do I put data about movies, directors, producers, actors, roles in meaningful tables? That's exercise 2. And figure out which relationships do I have, 1 to n, n to m. And then 3 is ask some queries. Like here's questions, in which year was Forrest Gump released, who directed Django Unchained? Just write some SQL queries. That's the exercise sheet. It's simple enough, lets you play around with SQLite, and it's a lot of fun, and of course make it bigger, find more queries. I think it's a really good exercise sheet to get started with this whole topic. And you need it for coming lectures. Robin, you had a comment, or?
Yes. For
Yeah?
the exercise sheet, string literals in SQLite are done with single quotes. Double quotes also work sometimes, but
Yeah.
not always, so use single quotes if you can.
So Robin pointed out that it's single quote. So if you put, what happens if you put double quotes? It's about quoting. Yeah?
It works as long as it's not a valid table name.
But Robin, I'm trying to understand, why do you need quotes at all if I use a tabulator?
No, in the SQL queries, not in the data set.
Okay. The question is, oh yeah, let's do that. Last thing we do. Maybe we want just a particular query here. From movies where title is, and now the question is, how do you write The Dark Knight, right? And I think what Robin says is you have to put it in single quotes. Is that what you're saying? Yes. Yeah, you have to put that in single quotes, yeah, because you need that for the exercise sheet. No lecture next week. You have 2 weeks for the sheet. It's a lovely sheet. Any questions right now? Okay, no questions. See you in 2 weeks. Bye.